But with that first step from the Eureka, there were other things that we immediately went to work on. Shell The Hague was ready to build a dynamically stationed rig and give a 5-year contract. So by accelerating our program, getting some model tests done, and working with the right people within SEDCO, we were able to convince Shell that we were the one to do it, even though Global Marine had been working with Shell for 4 years on the same project. But that was capability of people we had in-house with people like Duke Zinkgraf at the Baylor Company. Bill Baylor was still there working hard at dynamically staying. A big guy named Bill Foster. And these guys had really done the Eureka. And so we were able to take advantage of what had been learned there, but make a step from really wireline, taunt wire, over to acoustical beacons, and rather than analog processes in the computer to go to digital. So we had less than 6 months in there to really change it and make it where we were happy with it, and Shell was happy with it. And from the letting of the contract on the first dynamically stationed drilling rig ever built, it was out in the water DPing in 13 months.
Wow. This was a ship, wasn't it?
It was a
The
ship,
first one was a
445 foot long, but it was all because SEDCO had some internal people, with the people that I mentioned at the Baylor Company, that poured all of their technology effort into it at that time.
Did Earl and Wright design it?
Earl and Wright designed the hull,
Yeah.
And did a lot of work on making sure that we had all the places for the thrusters to go in it. And at the last minute, you decided you needed 2 more thrusters to satisfy Shell, and find those and mechanically to get it in all in 13 months was amazing. We went to a Japanese yard that they really said, hey, we're with you. We want to learn on this too. So they made it work. Yep. We built 2 others immediately. We built the 470 class. We made them a little longer because Esso came to us and they said, hey, we need a dynamically stationed ship. And then BP immediately came and said, hey, we need a dynamically stationed ship. On what all of the companies at that time were looking at a around the world drilling program where you carried all the material with you. You didn't have a workboat, and wherever you went, you just dug holes to basically take the seismic information that they had and drill a well in there so that they could zero in their seismic.
Test.
And they drill a well and drill it right on one of the seismic lines or on one of the corners, and then they could say, hey, look, here's what we had, and let's come back and do some more seismic in this area or the other. So it was a worldwide tool, really seen, like a lot of Africa had already had the seismic work done, but it didn't have any kind of cores to really tell what they had. But the ocean drilling program, we mentioned that, but that's one of the highlights that I personally feel an accomplishment in, of being able to work with a scientist and seeing how something is needed, and the vision that they have to go out and do it, and then the vision that the contractor has that says, hey, we can go out and do that. And there was, of course, the first program with the Glomar rig,
right.
And they did a lot of work. And then I think this rig has done a tremendous amount at the science end of it. If you really read their book and see what they have, showing where the North Pole has been all the way over the world, including the South Pole, and dating it, and cores, and then going to Antarctica and getting the information to show, do we really have a hole in the atmosphere? Is there a problem with that? And covering many of the scientific things is really where the government ought to be spending their money, is going and finding out some of these primary things.
So this is a government industry cooperative effort that really worked and had lots of results and benefits.
And academic.
And
academic, because as you go out and you meet these people, I made one of the cruises, and you meet it, what it is you as a scientist have this theory that you've been working on your whole career, and somebody's paying for it and your hair's getting grayer and you don't have the information that really will prove or disprove your theory. And it would be good for science to have that. It may help us as citizens of the world to be able to have this information. And so what they do is they allocate a time, and they say, okay, we've looked at your program, it sounds like it's worthwhile. you gather your team together, and you're going to have a 30-day time period that you're going to have. You can go out and core and use the facilities of the 471. And with that guy pulls his people in, and they get on the ship at the right time, and they go to location, and they pull their cores, and they look for the bugs, and they do everything right aboard ship. And before the ship comes in, they publish it. So they have all the computers and everything on board, so that while the scientists are together, they can all agree, and out comes a publication on it. And then that's distributed to all the scientists in the world, and the guy sees it and says, hey, look, I really could find out. Or you look at an oil company and says, hey, we've been looking to find out where this major fault went. Here's one of the theories, and we believe we can prove it. So I think it's the type of thing that maybe more so than space, if we're taking some of our money and efforts and applying it to something that's going to help people more. It's nice to see the pictures from the Hubble. It's nice to talk about going to Mars, but we may get more bang for our buck by scientifically attacking some of these things here. By being an engineer with an oil company, I've been in every state of the United States, and 86% of all the foreign countries in the world. This gives you a base of better understanding people and origin of people and what people's are made out of.